So today our stoichiometry video will be on the question of what mass of calcium phosphate will be produced if a 1.75 gram sample of calcium hydroxide is neutralized in excess phosphoric acid.
So first things first, we need to set up our equation. And now we know how to balance equations right now. We have this set up. Now all we have to do, like all the charges are set. So let's just now balance this out. So here we'd add a 2. Here we would have a 3. And over here we have a 6 to balance out the amount of hydrogen, the amount of calcium, and the amount of oxygen in each of these. So as soon as we have our equation that's already balanced here, we're able to tell what moles or what molecules that we want and the molecules that we have in our equation. So before we do this, we need to have our start and end points. So our want is the mass of calcium phosphate, correct? Our starting point would be we have calcium hydroxide, because this is a neutralization problem. So it starts with an acid plus a base, and then would yield to a salt and then water. So we have our water here. Our acid would be phosphoric acid. Our base is calcium hydroxide, and then our salt would be calcium phosphate, and then our water. So our starting point would be with calcium hydroxide. So we're going to start with calcium hydroxide.
So what do we have and what do we start with in our stoichiometry problem?
So what we have is 1.7 grams of calcium hydroxide, right? So we have our calcium hydroxide, 1.75 grams. Now what we want is the mass of calcium phosphate. If we go back, we reference to our balanced equation, we only have one, it's understood as a 1 calcium phosphate molecule. So we start with our calcium hydroxide, which weighs 1.7 grams, correct? And now what we want to do is, we're just going to basically do dimensional analysis. And we're going to want to cross out grams with grams. So what we're going to do is find out the molar mass of calcium hydroxide. So calcium would equal 40.08.
And this is all from the periodic table?
Correct. So oxygen would equal 15.99. Now since we have OH2, we distribute the 2 to each of them. We multiply it by 2. And we get hydrogen would equal 1.01 times 2. So once you get these measurements from the periodic table, you multiply and then you add all of them together. And this totals 74.08 grams. And now this grams, on top of this would be 1 mole, because this equals 1 mole of calcium hydroxide. So we have our 1 mole on top. Now what we want to do is go from grams to moles to moles to grams in order to figure out our mass of calcium phosphate. So now what we're going to have is the moles that we want. So we want this 1 calcium phosphate. So we put a 1 mole over what we have. Now we have 3 moles of calcium hydroxide. If we reference back to our balanced equation, it'd be 3 calcium hydroxide, right?
Right.
So we'd have 3 moles of that. So we have the moles that we want over the moles that we have.
And this is the ratio?
Yes, this is the molar ratio. Now what we want to do is, since we crossed out grams and grams here, moles and moles are being crossed out here, we want to cancel out moles and
moles.
Right, so we're going to have 1 mole here. And this is going to have the mass of calcium phosphate, which is approximately 310.1 grams of calcium phosphate. Now what we do is we can easily just cancel out our units. So cancel out our grams, our moles to moles, moles and moles. So then we're left with our grams at the end. Now what we do is we simply multiply everything on top. And multiply the bottom as well. Multiply by 3. So once we figure out our top and our bottom measurements, we can easily just divide those and we get approximately 73.17 grams of calcium phosphate. 73.17 grams. Now that we have our grams, though, we have to look back to our what we had. was 1.75, correct? We had 3 significant digits here, so we need 3 significant digits here. In this case, we have 4 with the 73.17. So how do we get to 3 significant digits? Michael, how do we do that?
Reround the 10th spot in the decimal to 2 because 7 is greater than 5.
Right. So we would have 73 point, what, Michael? Point?
0.2.
0.2 grams of calcium phosphate.
And what kind of reaction is this?
This is a neutralization reaction. So it would have, we would start off with our acid, our base, and out of that we'd get a salt and water. And so this is how much your calcium phosphate would weigh in that equation. Approximately this, grams. So we just went from grams to grams, moles to moles, and then moles to grams.
Which is stoichiometry, right?
Correct.
And another name for stoichiometry is dimensional analysis, right?
Yes, except involving just grams and moles.
Yay.